Whoa, whoa, whoa! Unit 2, the Living World Biodiversity Review. So here we're going to be defining genetic diversity. So genetic diversity is just genetic variation among individuals of a population. Species diversity is the number of species in a region. And then we have ecosystem diversity, the measure of the diversity of ecosystems that exist in a given area. Number 4, describe how the picture to the left relates to genetic and species diversity. So this shows how the drastic reduction in the number of a population can lead to the loss of genetic diversity. Thus, the effect of the bottleneck effect. Compare specialist to a generalist species. Give an example of each type of species. So let's start off with the specialists. They're organisms that have a narrow range of tolerance. They have very specific needs. Example, we have the koala, the panda, and coral reefs. We have the generalists. So they're organisms that have a wide range of tolerance. They can use a variety of resources. Examples, my favorite example, the raccoon, humans, and coyotes. Number 6, is a generalist or specialist more likely to survive in a changing environment? Explain. That would be the generalist, of course, because they can adapt to use a variety of resources and live in a wide range of habitats. Number 7, match the following. So let's match them. Zebra mussels would be the invasive species. Galapagos tortoise, endemic species. American alligator would be a keystone species. Tiger salamander would be an indicator species. Norway rat would be a generalist. And then giant panda, the specialist. Number 8, define species richness. And instead of how it is calculated, we're going to go with what does it mean? Okay, so define species richness. So species richness is the number of species in a given area. The more species there are, the richer the sample. And then define relative abundance and how it is calculated. So relative abundance is the number of individuals per species. So to put it in other words, we're dividing the number of species from one group by the total number of species from all groups. Number 10, what do these two things reveal about an ecosystem and why? So the two things that are revealed, y'all, is that it reveals the biodiversity of species diversity in an ecosystem. It also shows the number of species in an ecosystem, as well as how many individuals of these species exist in the ecosystem. So fill in the chart below on the different types of ecosystem services. We have provisioning, and that means goods produced by the ecosystem. Then give a real-world example. We have lumber, crops, rubber, medicine. Regulating. So we have natural ecosystems help to regulate environmental conditions. Forests are considered to be carbon sinks. Cultural. So there are cultural and aesthetic benefits. National parks. We go out there to bask in its beauty. Supporting. Provide a service that would be costly to humans to generate. Pollination. So, ecosystem component, the honeybee is responsible for pollination. The water cycle provides clean drinking water. Forests are considered to be carbon sinks. Bats, they are pollinators as well, and pest controls. Bacteria, they're responsible for the decomposition. Coral reef provides sources for certain medicines. Tourism and fish production. The wetland, we have flood control. Number 13, describe 5 ways that humans have disrupted ecosystem services on Earth. So, first one is deforestation. Deforestation has led to cutting down and releasing excess amounts of carbon back into the atmosphere, leading to climate change. Then the second one would be pesticide. Pesticides have led to the reduction in the bee population, which has decreased the rate of pollination. Number 3, clearing wetlands have led to less flood control and more damage from storm systems. Bottom trawling has led to the destruction of coral reefs, which provide habitats for fish and other species. Finally, overuse of water and draining aquifers. Water can't replenish quickly enough to keep up with demand. Then we move on to the island biogeography theory. So, two islands, different distances from the mainland, have different rates of extinction. This is explained by the theory of island biogeography. "15. Describe the trends observed in the image to the right. As distance from the mainland increases, biodiversity decreases. As size of the island decreases, biodiversity decreases." Number 16. Why are island specialists susceptible to extinction? So, islands do not have an endless supply of resources. So if the environment changes or there is an overuse of the resource, then they will not be able to adapt. What is the range of tolerance? How can one determine what it is? So, the range of tolerance is the conditions in which an organism can survive. Many different physical, abiotic factors influence where species live, including temperature, humidity, soil chemistry, pH, salinity, and oxygen level. Number 18, define the terms in the picture below. So we have the zone of intolerance. This is the area outside the geographic range where a population is absent. So actually, I'm going to be rewriting that down here where there's more space. Then we have the zone of physiological stress. The area in a population geographic range where members of the population are rare due to physical and biological limiting factors. And then C is the zone of optimum. So this is the area where the population is in ideal conditions, allowing organisms to thrive. (19) What are some examples of natural disruptions to the environment? So we have fire, floods, diseases, volcanic activity. 20. Compare resistance to resilience in terms of ecosystems. So, resistance is the ability for an ecosystem to remain unchanged when being subjected to a disturbance. Resilience would be the ability and rate of an ecosystem to recover from a disturbance and return to its pre-disturbed state. 21. What biomes need fire for plant germination? So, prairie, savannas, and the coniferous forests. Then 22, we have, how have plants adapted to fire? Give at least 2 examples. So we have some plants have fire-induced sprouts, which are protected and lie dormant underground. Some have fire activated seeds which have tough outer coating and require fire to germinate. Our examples would be the shortleaf pine, and eucalyptus. Number 23, compare and contrast primary to secondary succession. Give examples of each. So primary. Occurs, when new land is formed or bare rock is exposed. Providing a habitat that can colonize or be colonized for the first time. So an example would be after a volcanic eruption. So our secondary for the secondary, a previously occupied area is recolonized following a disturbance. So the example here would be after a forest fire. So now we're going to define the pioneer community. So it's made of all living organisms that occupy an area undergoing primary succession in the beginning stages. Define climax community. This is the final stage of succession remaining relatively unchanged until destroyed by an event like fire. What type of succession is illustrated above? How can you tell? So we know it is primary succession simply because the ecosystem starts with bare rocks. So define a keystone species, give at least 2 examples. So I'm going to write that down here, y'all. So this species is crucial to keep the ecosystem in balance. Examples: the otter and the wolf. Then we have indicator species. So indicator species would be species that can be used to infer the ecosystem health. 2 examples would be tiger, salamander, and the golden toad. Okay, y'all, that's it for today. Have a good one.